Hi folks, we're going to take a look at page 92, number 13. So what they're asking us to do in this question is to first show that the point 1, 4 is on both of these given lines, and then they ask us to find the acute angle of intersection of the line. So first of all, just a quick note. We notice that these direction vectors are not parallel, which means that given that they're two lines in 2D, means there must be just one point of intersection. And since we're showing that 1, 4 is on both lines, we're actually showing that 1, 4 is the point of intersection here. Okay? So just recall how we show that 1, 4 is on a given line, and it's a very similar procedure if we were working with a line in 3D. So here, this R vector represents any point on a line. So in this case here, if that point was 1, 4, we need to show that there exists a t value that will make this right-hand side equal to 1, 4. And similarly, we need to find a u value that's going to make this right-hand side equal to 1, 4. So let's start with R1. Okay, so I need to find some t value that's going to make 1, 4 equal to 3, 9 plus t times 2, 5. Okay, let's take a look at this right-hand side. Okay, let's bring it all together under one vector symbol. Okay, so here I'm adding the x components, so 3 plus t times 2, so 3 plus 2t is the x component of any point on this line, and then I bring together the y components. 9 plus 5t represents the y component of any point on this line. So we need to show that these two vectors are in fact equal. Okay, let's figure out what t value will make the x components equal. So we have to solve 3 plus 2t is equal to 1. And so if I solve this here, well, 1 minus 3 is negative 2, divided by 2 is negative 1. Okay, so t has to be equal to negative 1 in order for the x components to be the same. So let's see if that same t value will make the y components the same. So I'm going to test 9 plus 5t. So 9 t has to be equal to negative 1, so 9 minus 5 is equal to 4, which is indeed the y component. So we've shown that 1, 4 is on the first line. Let's now do the same thing in the second line. I'll try to do a little less writing here. So if we look at the x component from the definition of the second line, it's equal to negative 5 plus 3u. So negative 5 plus 3u needs to be equal to my x component of the point, which is 1. So let's solve that here. U is equal to, well, 1 plus 5 is 6, divided by 3 is 2. So the u value has to be equal to 2. Let's now check that that same value gives us the correct y component. Okay, so let's take here 6 plus negative 1 times u, so 6 minus u, which is going to be equal to 6 minus 2, which is equal to 4, and that is, in fact, the y component of the point that I'm trying to show. So this tells us that the point 1, 4 is on both of these lines. Okay, let's go on to the second part. Second part asks us to find the angle at the intersection of these lines. Okay, so I've got these two lines, they intersect at a point, and, well, there's two angles that are made, this one here and that one here. Okay, we're looking for, actually we'll put that to distinguish between the two, we're looking for the acute version. So let's figure out how we're going to do this. So we're given direction vectors of both of these lines, or we have direction vectors, and we know that the direction vectors have to be parallel to those lines. So if you take this direction vector and move it the way I can do with any vector, and I bring it to that point of intersection, and I can do the same thing with this vector here, and I realize that the angle between the lines is the same as the angle between the direction vectors. Okay, now even if this direction vector was opposite, say it was here, okay, the angle between the two direction vectors would be this obtuse angle here. Okay, but since it's two lines that are crossing, we know that if you find the obtuse angle, you just have to subtract from 180 to find the acute version. Okay, but in the end, it's all about finding the angle between the direction vectors, and we can do that by using the dot product. Okay, so direction vector 1 here was what multiplies the t, so 2, 5. Okay, and direction vector 2 is 3, negative 1. Okay, and we do this by using both the algebraic and geometric definitions of the dot product. So on the left, I'm going to use the algebraic, and then on the right, I'm going to use the a geometric definition of the dot product, because this contains the angle between our two vectors. Okay, so on the left, I can take the dot product. So let's do that here. 2 times 3 is 6 plus 5 times negative 1. Okay, and then here on the right hand side, well, the magnitude of m1 is the square root of 2 squared plus 5 squared, so 4 plus 25. And then here, magnitude of the second vector is 3 squared, 9, plus negative 1 squared, which is 1. And then, of course, the only variable we're left with is the cos theta. Okay, so here 6 minus 5 is 1, and we'll divide these coefficients here. So 4 plus 25 is 29. Okay, 9 plus 1 is 10. And since we're then isolating for theta, we have to take the cos inverse of all this. That gives us our theta. And let's grab a calculator. Make sure we're inputting it into our calculator correctly. So here we've got inverse cosine, okay, of 1 divided by, and please make sure you're putting that denominator in brackets to make sure that the operations are done correctly. So here we have the square root of 29, okay, times the square root of 10. Close off the denominator bracket, close off the bracket for the cos inverse, and we get 86.63. So theta is approximately equal to 86.63 degrees. And since this is already an acute angle, that's our final answer. Like I said, had we gotten an obtuse angle, we would have had to subtract from 180 to get the correct answer. Okay, so main thing to get from this question here is a method for showing that a point is on a line, so something to add to our journal. And the other thing here is if you want to find the angle between two lines, you find the angle between the direction vector. And the convention is that you always take the angle which is acute. So if you find the obtuse one, just subtract it from 180 to get the acute one. Okay, that's it.